Hello, today we are going to look at spanning tree protocol, also known as STP. STP is a layer 2 loop prevention mechanism in switches. So imagine a wall without spanning tree. There will be a lot of problems in the switch network. For example, a broadcast storm. So looking at our topology, if communication is to come from PC1 to PC2, this communication has two options from switch number 1. Either it goes out FA0/24 via switch number 2 via switch 3 and to PC2, or it goes via switch 1 straight to switch 3 and to PC2. So if this communication is coming from PC1 to PC2 for the first time, so this switch number 1 is going to send a broadcast message out all of its ports. In this case, it's FA0/24 and G0/2. So this broadcast message will hit switch number 2, is also forwarded out G0/1. It hits switch number 3, it's also forwarded out back G0/2. It hits switch number 1 again, and it goes out again FA0/24. So it keeps circulating. Likewise, the first broadcast also that was exited out G0/2 also is going to go through switch number 3, exit out G0/1, and exit again FA0/2 of switch number 2, and it keep on circulating. So this circulation of this broadcast message in the switch network will lead to a broadcast storm, and this broadcast storm will take down the entire network. So the way STP works is now the switches will engage in a root bridge selections, or select the master switch in the network, and all other switches will now try to find a way to reach the root bridge. So the selection of a root bridge involves what we call the bridge ID. Bridge ID is the priority of the switch plus the MAC address. So the switch that has the lowest bridge ID will win as the root bridge. So if you look at these switches, by default, all of them has the default priority, which is 32768. And if it is for VLAN 1, you're going to add 1 there, that will give you 32769. So by default, then all of the priorities for VLAN 1 is going to be 32769, since we are dealing with only VLAN 1 as the default VLAN in this topology. So the next criteria is who will have the lowest MAC address, since all of them have the same priority. So if you look at the first 2 digits of the MAC addresses in all the switches, they are all 00. So we move to the third digit of the MAC address in switch 1, which is 3. The third digit in switch 2 is 0. The third digit in the MAC address of switch number 3 is E. So note that MAC addresses are written in hexadecimal. That's from 0 to 9 and A to F. So obviously, switch 2 has its third digit in the MAC address as the lowest number. So it will automatically win as the root bridge. So jumping into switch number 2, we can issue the command show spanning tree. And now we can see that here it's indicating this bridge is the root. And it places all its ports, in this case G0/1 and FA0/24, as designated or forwarding state. So the root bridge normally have all of its ports on forwarding state. So the other switches will now do the next step, which is to calculate which port are they going to use as a root port. So this is DOS based on the link cost. So the link cost for 1 GB is 4, and the link cost for fast Ethernet or 100 MB is 19. So here, starting with switch number 1, since it has a link going directly to switch number 2, which is the root bridge, but it's a fast Ethernet interface, so the link cost there is 19. From switch 1 also, it can go via switch 3 and hit the root bridge, which is switch number 2. So since out this 0/2 via switch 3 is a gigabit interface, it's going to have a link cost of 4. So from switch 3 to switch 2 also is gigabit interface, 1 gigabit, so the cost part is going to be 4. So now switch 1 will say now if I want to go directly to switch number 2, my link cost is 19. So if I want to go via switch 3, it's going to be 4 plus 4 here. That's going to give me 8. So then I will use that part. So that will make my G0/2 as my root port. Okay. So then if we jump to switch number 1, we issue the command show spanning 3. We can see that the G0/2 is the root port with a cost part of 4, and it's on forwarding state. So now the next port here, which is FA0/2, will be placed either on block or forwarding state. So, and that is exactly what you are seeing there. FA0/2, FA0/24 in switch number 1 is on block mode. So that means this port will not allow broadcast message to go exit out or enter that port anymore. So that's also going to break that loop that was happening in the first time communications or broadcast messages were forwarded out. So the same thing will be done in switch number 3. Okay, switch 3 will also say if I want to reach the root bridge, which is switch number 2, I can go via switch number 1 and to switch 3, or I can go directly to switch 2. So if I go directly to switch 2, the cost for this link is 4. If I want to go via switch number 1, it's going to be 4 plus 19, which is 23. So obviously 4 is lower. Then it's going to say, okay, my root port is G0/1. G0/1 here will be identified as the root port for switch number 3. So if you jump right into switch number 3 and issue the show spanning 3, we can see that the root port is the G0/1. As you can see in the topology here, that's the root port. And now the other port, which is G0/2, which is the port connecting to switch number 1, will be placed on either block or port mode. But since one port is already blocked, so now that port will be on designated mode or forwarding mode. So remember, we say that the root bridge, which is switch 2 in this case, will have all of its ports on designated mode. So sometimes we want to say, no, switch 1 has a higher MAC address to switch number 2, but we want to force switch 1 to become the root bridge for some reason, because this switch has higher capacity than switch number 2, or so on and so forth. So to do that, we can reduce the priority on this switch. So remember, we said the priority by default is 32768, but we can reduce it by using a multiple of 4096. So to do that, we can go to the command prompt and say spanning 3 VLAN 1 root primary. So this is going to force this switch to become the root bridge. So if you issue the command again, note that we said FA0/24 was in block mode. So, but if you issue this spanning 3, spanning 3, now we can see that it say now this port is now on listening. It's no more on blocking mode. Before it was on block mode, FA0/24, but now it is on listening mode. And this can be done in 15 seconds. It jumps to another state. So if I say so, now it's now on lining. So it was listening LSN, and now it's on lining states. So it is on lining state. It was from block mode, okay, from block mode, and it goes to lining. It goes to listening states, and now it's jumping to lining stage. So finally, we should see it to be on forwarding mode. From block mode to listening mode to lining mode could be 15 seconds, and from lining to listening could be 15 seconds, depending on the STP that you are using. Okay, and you can see how long it will take to switch over, and finally it is on forwarding state, because this switch is now the root bridge. This bridge is the root. So, and we said all ports of a root bridge are placed on forwarding state. So switch 1 now is the root bridge, as you can see, and also it has reduced the priority less than 32768. Okay, so the other switches will now calculate and select the best path to reach the root bridge. So know that switch number 2 was the root brick before, but now it has block FA0/24. So you have to calculate the best part. You will say, okay, if I go via switch 3, it's going to be 4 on this gigabit. 4 cos here, that's 4 plus 4, that would be 8. That will be lower than going via the fast internet interface, which is the cost of 19. So that's why it's blocking FA0/24 and using G0/1 as its root port. Okay, G0/1 as its root port. So that is for STP. We will be looking at more STP concept in our subsequent videos. And if you enjoyed this video, please subscribe, and I will see you next time.